Hi, good morning, Pepper.
Hi, Sammy.
How are you?
Good, good. How are you?
Good, good. We were kind of
So
waiting for last week. It looks like you were not able
yeah,
to make it.
I was traveling last week. I'm also traveling today. I'm actually at a Future Bridge event in Dallas talking about data center efficiency. But
Oh,
I
good.
figured I'll drop out of that and talk to you guys a little bit.
Sure, very good, very good. Thank you for joining.
Yeah, absolutely. You're in Santa Clara?
I'm in Portland, Oregon.
Oh, in Portland. Excellent.
Yes, 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 yes. Yeah. So what do you focus on, Perfect? Where are you located?
So I have multiple hats. One hat is I'm a professor of computer science. I've worked with Intel for many years. I do design for servers. I do server CPUs, server memory, and Intel was actually very nice to me from the start of my career at Purdue, and then eventually Carnegie Mellon. I was funded by Intel. Now we have two projects with Intel. One is this transformative server architecture center, and then the other one is on packaging with the chiplets.
Okay.
My other hat is the Data Center Efficiency Association. So we have a platform for with three calculators. One is a DC energy flow, and it gives you an index on the PUE scale, but it's an integrated index that takes into account also heat recycling and on-premise renewables. And then we have a calculator for the IT stack, and that's, I guess, why I'm sort of, Shruti suggested I join you guys. We have a number of KPIs. You guys call it, I guess, IUE. We call it just the IT index, or IT index. It's on the same scale as a PUE index, and you can combine also the two indices because they're on the same scale in a geometric mean. And so if the collocator is doing better, it can help the IT customer a little bit in their final index.
Right. Okay.
We also have certification. So we don't do the certification, the auditors do. But based on the index you reach, you can also get certified on our platform. So.
Okay. Good. So is that kind of auditing kind of a framework to certify it, or?
So we train auditors. We have independent auditors that check the numbers are entered in the platform and validate that it actually was measured properly and it was entered properly, and then we give the label.
Oh, very good. Okay. Thank you. Hi, Gopi and Eric.
Good morning. You look comfortable.
Good morning.
We're a little short on quorum, though. Looks like we're having an Intel meeting. Thanks, Safi, for making it.
Yeah, I think last 2 weeks we had some IBM folks and Broadcom, a couple of course, but we were not able to get any other Intel or any Microsoft other folks there. So maybe they might join later. So
yep. I'm not very punctual at 8 o'clock either, usually.
Right. So just to kind of introduce the people here, right? So I'm Sami Nachimute. I'm part of Intel, and I'm chairing this Workstream. And on my background, I've done a lot of firmware-related work across different areas of the data center or all the products within Intel.
Okay.
And also I support a lot of hyperscalers. Maybe Kobe and Derek, you can give a quick intro.
Go ahead, Gopi.
Yeah, sure. Hello, everyone. This is Gopi. I'm a senior technologist within Intel, mainly working on the federal, data centers. And mainly my specialty is in the area of workload optimization on single node to large scale clusters, both from the angle power performance and, complete optimization of the hardware and software stack. Go ahead.
Yeah, and I'm Eric Dale, and I co-lead the sustainability project at OCP. been at Intel about 35 years. I'm a lead cloud technologist in DCAI.
Okay. So let me just introduce myself too. I'm a professor of computer science at EPFL in Switzerland. And before that, I was a full prof at Carnegie Mellon in computer engineering. And before that, I started my career at Purdue. I work with Intel with my professor hat. We do server design. So we now have two projects. One is this transformative server architecture center, which Intel kicked off. We helped kick that off. And I also now have this other project with my EDA folks on packaging technologies for chiplets. My other hat, which is this one that you see here, is that I'm the founding president of the Swiss Data Center Efficiency Association. And this association is a nonprofit. What we have is a platform for DC energy flows that calculates an index on the PUE scale. It takes into account heat recycling and on-premise renewables. We have an IT efficiency calculator as well, which is on the same scale as a PUE DC scale. And these indices can also be integrated in a full stack to get one number. We have a platform for customers who could use this, but we also certify based on this index that we generate. If you pass a certain threshold, you then get certified for 3 different grades of a label.
Okay. And what are you on the IT side? What are you guys measuring?
So we have a number of KPIs. I've already presented this at a couple of the OCP meetings. Our KPIs are not open at this point, but we actually plan to open it. I've presented it to the OCP task force a couple of times. Basically, it's utilization, obviously. So that's one category of KPIs, and we do utilization. We look at consolidation, we look at virtualization, we look at utilization of compute, CPU, IPU, GPU. We look at memory, utilization of memory. We look at utilization of disk, but we also look at technology excellence. How much of it is flash? How much of it is hard disk? We do a similar set of KPIs then for shared storage, and we do similar set of KPIs for network. And we also have, we reward both technology excellence, for example, in PSU and PDUs, and we reward higher temperature classification for the components as well.
Okay.
So that together
like
is
free air kind of support.
Yeah. So that together all comes into one index, basically.
Yeah, maybe I've seen that presentation. I don't think I must have missed it.
Yeah. I can present it to you guys at an upcoming meeting. So
yeah, so you go a little beyond the scope of what we've talked about so far here, but some of what you're measuring obviously is what is proposed to be comprehended here.
Yeah, and my goal is to, help from our side based on what we know and our current sort of experience with customers, but also help reach sort of leveling grounds where these KPIs, whatever KPIs you guys come up with together with my help as well as part of this team, will eventually be part of OCP, right? Which should be open, right? We see right now in our market, the European market. I'm in Switzerland. The European market is mostly a colo market, and PUE is fairly well established. There are a bunch of labels out there. We also are compatible with those labels, so we accept them, and people know how to measure them. IT is a nightmare. Customers, we have customers, and so we have. We also work with partners that instrument the software stack so they can generate KPIs. So we have a partner in Munich called CheckMK. They already have a reasonably sized market for instrumenting software stacks and measuring KPIs. So they've created a dashboard for us as well.
Okay. Yeah, we haven't thought too much about instrumenting stacks, right? I think it's not a third rail, right? But it's a huge barrier, right? If you have to put software on someone's machine to measure it, your scope of what you're going to be able to measure just got a lot smaller. There's a lot of scenarios where people can't or won't put software on their machine.
Yeah, and the question also becomes, and this is also interest to academia, is that what would be hardware software co-design technologies for proper instrumentation? What should be done in hardware, and what is it
right,
acceptable
right.
in
Yeah,
software?
that's a very interesting question. Agreed.
Yeah.
Yeah.
Yeah, I think that definitely we need to really have a discussion on what are we want to measure and what we want to reflect as a numbers. Are they even willing to share from even if you generate those numbers? Is hyperscaler willing to share it outside or not? Right? There's internal facing. There's also external facing. Right?
Yeah, there's
Right,
what
so-
you want to know about your machine and what you're willing to publish about your machine.
Right. Right.
So I'm hoping that while we mostly focus on hyperscalers, that we also look at markets that are complementary to hyperscalers. Hyperscalers are being hosted by co-location
Yep.
providers in
Yeah.
Europe, right? So they're, first of all, Intel's chips are everywhere, so it doesn't matter whether it's a hyperscaler or it's Dell or HPE. But I think this conversation should include, folks who really just want to find out what the heck is going on. Where's that electricity going, right? We're even co-location providers. They're doing PUEs of 1.2, right? That basically means that all the electricity is being delivered to the IT, and nobody has any idea what the heck's going on in the IT.
That's right.
And I think,
but generally,
yeah.
your colo provider, right, the guy that's motivated, he can't put software on any of those machines. Right?
No, they don't put software on the machine. So the software is actually being put by the customer themselves. So for example, CheckMK, this is our KPIs. We could talk about other KPIs, or we could talk about things that you need hardware support for. But even for our case, this the customer that's running CheckMK, the software, the instrument.
Yeah, we'll start arguing, as you probably know, in the EU about the tenets of a colo being mandated to provide just a physical inventory of what's in the racks they rented.
Yeah, that's
what's running on them on a real time basis, right?
Yeah.
Because all today, I think by the terms of colo, all they really know is you're committed in actual power and your network ports that you're using and whether you're oversubscribed on them or not, right?
Yeah,
that's about all you.
Absolutely.
That's all
you got.
Yeah. Anyway, yeah.
Yeah.
So,
good. Thank you for joining. Go ahead, Eric. You want to say something there?
No, your meeting. I think we're gonna decide how you want to use the time today.
Yeah, I think there's two things. I had, I think, network and storage discussion last 2 or 3 meetings. We had Dell, IBM, and I believe Broadcom joined, and we didn't hear Eric, you were kind of some of the areas that you want to discuss on network, and I didn't get a Shruti join. So maybe it'll be good to go over that. And also I have a couple of open areas I want to get it discussed, like especially sharing part. And also I put a couple of slides on getting kickstarted on the performance things that we want to start focusing on it.
Okay.
I can go over that. Probably we can reiterate when team joins, or even next week as a summary there. So let me start sharing the slide here. So so what do you prefer, team? Like, want to just touch on this performance thing, and we can again, it's not really like going through the details. Then I can go over the remaining the other areas. or we want to
Sure,
focus on
sure.
the IUE side?
Yeah, no, that's fine. Let's do that.
Okay. So the basic thing is, when we started the work streams, right? We purposefully we said like, let us focus on improving the IT infrastructure power energy area, or trying to define a metrics there so that we can make some progress and conclude on that. And especially when we were looking at the performance angle, there were a lot of studies done, but no actionable final decision was made. So there was a lot of controversy regarding what type of things that we want to go for performance. So we purposefully said like we will focus it later after completing the IUE portion. Now, given that we made enough progress, we defined the metrics. Now we are working on creating sustainability profile to basically get the data from system and reflect it back. I think that work still need to be continued to conclude, but at least we see a lot more progress there. I think maybe it'll take a few more sessions to conclude the final metrics on the getting from the system. But other than that, I see like most of the work is done. So I think it's probably time to start discussing on the performance angle. What are the things we want to consider? In that, I just put one slide just for us to kind of start thinking now, then I will go to the other ones. So the basic thing is we want to have a focused discussion on what work was done before, like to really understand. I think we can send you some of the white papers, or if you guys seen some white papers, probably share the white papers between among us, so that we can read those white papers, and then we can come back here and discuss. Here is a work was done. Here is a conclusion. That will help us to kind of, we don't want to rehash the same thing that we was done before, and we want to kind of focus on what is new that we need to focus on it, right? That is one. The second thing of approach what I'm looking is, what are the other thing, if you look at some of the papers, it really calls out benchmarks, right? We really need to align on what benchmarks we want to go after, right? Even this specific things, do you want to do a benchmark before system is put on a data center? Does that benchmark include all the parameters in your data center, right? For example, network and storage. Can you able to do all those things? Or can you do a benchmark just a standalone desktop, right? Benchtop and really like run everything and say like, here is a benchmark I want to get, and this is what we want to align on it, right? That's one area we need to start thinking about. How do we align on the benchmarking? First of all, what benchmark, and what are the parameters, how you can run it, and how you want to align it? Does the benchmark includes different loads, right? Is it always you go to the max, or you want to, if the data center is generally operating at 50%, do you want to do it in 50%? Or 40%, 60%, like the person load factor, right? That we need to understand. And the other one I'm kind of thinking is, what energy we want to go and base it on, right? Do you want to look at DC energy as an input and give a benchmark, or IT energy as input and give a benchmark, or compute energy part of the IEE portion, right? Do you want to take just compute energy that is going in and give a benchmark, right? That's where I'm kind of thinking at a high level. I would like to hear from others. What do you think?
Since I'm new to this conversation, and I also have done for quite some time benchmarking in the data center space, we have this suite of benchmarks called Cloud Suite. Now it's in the 4th generation. Are we talking about actually running software and measuring something, like running spec? What are we talking about here?
There's also two things, right? Do you, that's kind of open here, right? That's what I'm set this brainstorming session.
Yeah.
If you want to go performance per joule or what, however we want to base on it, right? When we say performance, what is that? There should be some benchmark numbers, right? Because
Right.
if you take a compute system, you can have
Yeah.
CPUs, GPUs, accelerator, a lot of different things, right? And
Right.
it may not, one benchmark may not meet all the different things in your systems, right? It may,
Right.
one may perform better and another one may perform worse. And as an industry, if you want to publish one, is there one number, one benchmark that we can publish, or you have to publish 10 different benchmarks? Then people need to compare, right? And is it an
Right.
active benchmark or is it a passive, meaning like before you put on the system, you run it and you call it good, or you have to keep running and getting the numbers, like all the memory bandwidth and performance and the compute cycles, and publish it, right? Where we want to focus on it and how do you want to align? I think that's the general alignment question here, right?
Okay. So first of all, Spec has recently released a 3, I think, micro benchmarks, which they call compute bound, memory bound, and IO bound. And there was a release of a specification for performance and power rating of servers. That's a simple way of doing this. In the data centers today, what people care about is throughput and throughput with tail latency constraints. Those are the only two. So depending on the service, if you have a service that's an online service, it's maximizing throughput with a particular tail latency constraint. If it's a batch job, because you're training a AI model, that is just throughput. There's no, it's not an online service. It's not, it doesn't. So those are basically the basic 2 metrics that are used. Having said that, also installing a software stack and tuning your workload just so that it's doing the right thing in terms of tail latency constraints and maximum throughput, that's also, it's a major challenge today, both in industry and in academia. We don't have proper prescriptions for how to do that quickly. So I guess you're considering also for the customer, it has to be easy to use whatever you come up with.
Correct. It's the number that people can publish it, right, at the end of the day. If they're not able to publish it outside, it's more of internal tools for tuning. Like PUE, right? PUE people are comfortable in publishing because they know what power energy they're getting into the data center and how much they're giving to IT, right? It's the clear boundary, so they're feeling comfortable in publishing it, right?
Yeah, I think so. We've covered a lot of ground already, right? But so one of the questions that we need to, there's a couple of points I think we need to put on the table before we get too carried away, right? The first is the colo discussion that we were just having, right? What do we do, if the data center operator can't control what's run on the machines? Where does this KPI come from, right? And in theory, the tenant would have to, as you say, publish it or provide it, right? We'd have to make, for a colo operator to say something about performance per energy, the tenants, the rules for tenants and colos would have to change, right? They'd have to tell you an inventory of what's in there and somehow the performance characteristics of that stuff, right? That's a complete change from the way things work today, right? Or there would have to be, it's a little bit like the discussion we've been having about embodied carbon, right? Assuming the data exists, which is a bad assumption today, but if you generate the embodied footprint of the devices, there has to be an inventory you can associate it with and some place to go get that information to associate with the inventory. And the performance data, it seems, is more in that category. There has to be a place to go get the performance data given an inventory. So it feels like we need a third-party curated set of data that the ecosystem is okay using, right? And maybe it's not precise. That begs the question of how well aligned it is to the specific configuration that actually gets deployed, right? But to get anything that's even directionally correct, there has to be, you know, some way to identify the equipment and identify the performance metrics associated with that equipment, rather than trying to mandate that you have to go run something on the equipment and publish it. I think the mandate of running some new piece of software is a non-starter.
Yeah, I think that we agree, right? We cannot force the people who have to run something new. It need to be part of a standard or the data that you are already getting out of the system, right? If you want to go on a static, right? Before I onboard the system, I can run whatever the things I want to run and say like, here is my capability, not really like what I'm getting it, right? You want to have something dynamic. Is that what I'm hearing, Eric?
Yeah, so I think that's something else we kind of jumped over, right?
Right.
As a guardrail here, we have to think about, if we look at like regulation that's starting in the EU already with the EED, the Delegated Act updates. There are really kind of two numbers we care about, right? There's a capacity number, right? What is the performance capability of the hardware deployed? And then there's an average utilization rate, or an average actual operating point as compared to that peak capacity. And we can use the same metric for both, right? But this is a challenge, right? Because, you know, because of a couple things that we know as technologists who've been in server hardware for a long time, right? The first is that the load line, right? We're now needing, you know, a peak effective utilization, which probably isn't 100%, but that's what most benchmarks would measure, right? Is peak performance at peak power,
Right?
Because that's how benchmarks generally get built. But the operating point on the lifetime average for a piece of equipment is nowhere near saturated, right? And one of the things people are concerned about is, what is that utilization, and can we drive that utilization up before we go deploy more hardware and allocate more power? Which the answer to that may not always be yes, but that's yet another discussion, right? We want to know what's the capacity of this and what's its operating point. And we know that the load line is nonlinear, right? If you had a utilization measure, your performance isn't aligned to the utilization metric, and neither is the power. Right, at 50% load, you're not at 50% performance, nor are you at 50% power.
Right.
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 You're probably at 80% power, and you're probably above 50% performance. Right. But where you are exactly is challenging. Right. So this dynamic, there is a need, I think, or a demand, I guess, for a utilization and operating point performance metric. But how to estimate it or generate it is an interesting discussion.
Yeah, so I think what we really want to say is even 50% performance on what particular benchmark, right?
Right. Yeah. Well, I'm just saying, when we talk about what we want to use for a benchmark, we got to think about what we want to do with the benchmark, right? So what's the nature of that benchmark? And obviously we'd prefer. So this has driven people to talk more about spec power insert, because they don't just measure a peak, they measure a load line.
Mm-hmm.
Right. But Babak is correct, right? I think for scale out digital services infrastructure, you care about throughput with a constrained tail latency. I guess spec power kind of does that, sort of, except it doesn't enforce a latency, right? Critical JOPS and spec JBP would enforce a tail latency, sort of, right? But spec power is a 2008 benchmark, right? That's 16 years old. and
yeah. So yeah, and JBB is, there have been articles published that show that JBB is not really a representative. We did this back then in 2012 when we introduced our own workloads, Cloud Suite, we already evaluated JBB, and JBB is questionable as a benchmark. But I think that I want to sort of make sure that we're on the same page as far as tail latency. Tail latency doesn't have to be end-to-end. Tail latency could also be measured at the server. So when you have a request, if there is variation in the runtime of that request, independent of throughput, right? You could evaluate that variability, right? There's a tail latency on the service time distribution as well, right? And that is, I think that's an important metric in data centers today, right? It's not, there are many ways in which you can maximize throughput, right? But latency for some services is super important. So throughput by itself is not enough for,
Agreed.
To characterize. Yeah.
Agreed. Yeah. Well, and to the term I think you were using was technology excellence, right? Obviously, if we had a way to measure, at what utilization can you maintain that tail latency constraint, infrastructure that can go to a higher utilization without breaking that requirement is better infrastructure.
Absolutely. Actually, we're now in my lab. This is my other hat at the university. We're looking at how do you optimize chiplet design from a tail latency constraint perspective. And there are a lot of services, if you disaggregate functionality in chiplets, there are services that are perfectly happy with 1.5 gigahertz clock, end-to-end tail latency. And if you run things at 1.5 gigahertz clock, you get a lot of power back from just bringing your frequency down and getting your supply voltage and threshold voltage closer to each other. And so I think this notion of tail latency and properly evaluating it is important for utilization for infrastructure.
Yeah. Although I can tell you as a guy with a background in CPU design, right, and architecture, there are workloads like AI inference that are memory bandwidth limited, and if we were forced to go down to 1.5 gigahertz, you'd slow those down 30% because they're memory limited.
No, I absolutely understand that. So if you consolidate, then this wouldn't work out. But if you disaggregate, well, I'm talking about long term, not tomorrow, then you could provision resources a lot more efficiently from a tail latency perspective. If you consolidate workloads that have different requirements, then obviously you have to go abide by the least common denominator in the requirements, in the constraints. Yeah.
Well, and obviously there's lots of. I can tell we could have an interesting discussion for a long time across a range of topics here. But where Sammy is though, what the OCP goal here is something we would propose that we start measuring on infrastructure, near term, right? On deployed infrastructure, and then whatever you're deploying next, right? Because the other challenge we've got, right, is we're already at, whatever 15 or 20 gigawatts of capacity deployed, right? And thousands of data centers all over the place, right? We're trying to get our arms around that and then track it going forward.
Yeah,
right?
Yeah, absolutely. I mean, step zero is super important.
Yeah. And getting traction, as you know, right? So let's talk through what you already got here, Sammy, right? I think there have been some efforts, not here in OCP, right? But there have been some efforts to go look at prior work. It sounds like Babak here has already done a survey at some point, right? We know the Green Grid and the Climate Neutral Data Center Pact also went and looked at what was available. I don't know how much is published of what they found, right? But being members of both groups, right, I could go dig some of that stuff up, right? And I'm not sure how exhaustive they were, but it's better than starting from scratch, right? In terms of what's out there, what's available to select from, and what are the kind of the pros and cons. One of the challenges here, which we spent a lot of time talking about in those groups too, is obviously, we're smart guys, but we're not the first to identify this as a need or a desire. There have been a parade of people over a long period of time that see this as a need, right? The ability to measure the performance capability and the actual performance operating point of infrastructure. So there have been dozens of papers written. I don't have a count, right? But it's a pretty impressive number, right? There's a material number of papers proposing for how to do this. None of them have traction, right? If you look around, nobody is doing any of the things that were proposed, right? So one of the challenges here now, we have a way to put some teeth in it, right? The theory being, I think what we're after here is to define a methodology here that is then a required element of OCP compliance, right? Where to be an OCP compliant implementation, you have this information, right? Whatever it is we align on here. And that would be, a big step forward, right? One of the things that none of those people had, right? Some of them were academics, others, were just good Samaritans, right? And some of them had status in the industry, but obviously nobody controls what all these data center operators and infrastructure owners actually do, right? Unless it gets regulated, right? Mandated by fiat for where you're trying to operate. And that may just cause an exodus from that geo, which isn't what anybody wants, right? So one of the things we have to consider, and this is obviously one of the criteria by which we go evaluate previous work, is why didn't this get traction, right? Why wasn't any of this adopted? What is it that they're doing wrong? And is it possible for us to do something better that makes it not so onerous to start using the methodology we propose?
Right. I think that's what I think at the end result, right?
Yes.
So can we create a OCP profile with what we need to get out of the system?
Yeah, like we're doing with the energy.
Right.
And that's another thing that we have that hasn't been available to anybody previously, right? Is that we're already working on the OCP sustainability energy profile for the management work group of what the hardware must be capable of, so that there's actually a standard set of energy information that we have. If we get associated performance with that energy, we could do perf per energy, right?
Right.
But the energy part was missing too. We've got some traction on progress on getting the energy part. Now we got to decide what we're after for performance.
Right.
So that was one topic. The other thing I'll say, and then I'll shut up, right, is we probably do have to think also about categories of infrastructure, right? So it's easy to come at this, and we probably should, right, thinking primarily about dedicated compute infrastructure and starting there. And that's okay. Yeah. But I think, a dedicated general purpose compute, CPU only platform without a lot of storage in it, that's one of the types of system, probably the majority type of system, but there are other types of systems. What about systems like AI systems with GPUs in them and big accelerators? And what about network gear that's in the data center but isn't compute infrastructure and you can't run a compute benchmark on it? What about data services infrastructure with a lot of storage in it? So how many types of energy efficiency do we need to pursue?
So we in SDA, we separate the KPIs for local storage, which is per server, versus shared storage. Those are but it's good that you brought this up. And I think also for AI and GPUs, fortunately, because there are fewer layers of software, it's much easier to come up with metrics to also measure what's going on.
Yeah, I think I was about, sure. Sorry, go ahead then.
No, go ahead. I think we're
I was about to bring this point, you need to identify a list of workloads where you run on a single node, just like CPU benchmark, pure compute, and then also on a cluster level where there is an inter-node communication from the storage network angle, like Graph 500 workload. And then when you consider all of those, then you can drive the metrics and then come back and say normalize it to performance per watt. and you can do that. So, and we need to select some of the AI workloads also, even for training or inference, whatever the perspective is, with variation from pure ML workload to LLM workload with the RAG framework and the super RAG framework. And then if you have those, so that way you have a composite, because all the data center infrastructure runs on basically various workloads. So we need to have a composite view of it. And then also, if you take cloud, we have a cloud suite benchmark already where you can develop the application instances to 1 to 100 to 1,000 and then measure that also. So combination of these needs to be selected so that you have a complete composite overview. That's my thinking, right?
No, I think the question is a static number, is it going to be helpful, right? Or not? For example, I could have a systems with a really high performing system, but those systems parked on the data center, but it's not even used. You might be using systems with I'm just putting theoretical numbers. Don't go on me, right? You could have systems which is really power hungry and not efficient. That's what's getting run, right? So at the end, what is a thing what we want to go after to kind of say, like, yes, static is important. It's part of a value prop on a systems, but is it a useful number at the end?
Yeah, well, another way to ask that question, right, is do we need, so one of the questions we need to address, right, which I think is what you're poking at, do we need dynamic metrics, or is a static metric sufficient to the need? Can we do what we need to do with the static metric or not?
Right. Is it
and that begs the question of what it is we think we need to do, so we should talk about that.
Yeah.
Right. If you go with the static, how are we going to approach the problem, right? If it's then basically like a one-time number, you get it, then you don't need to worry about it, right? Or is it even static is keep on modifying it, then it becomes more dynamic, right? And if it is dynamic, what are we measuring? Like benchmark, we were talking about it. It may not be applicable for dynamic, right?
So I'm a little bit confused here. What is static? What is dynamic?
Static means you are take a system away from your data center and run your benchmark, right?
Okay. So by the way,
and publish a number, right?
Yeah. So Europe, I think, is regulating this right now. So there's their latest. I'm also part of this discussion, but I think they are looking at static metrics for servers. Right. Yeah, I think what the community really needs is a way of measuring something when they're using their servers, not what they're going to buy. So usually in my presentations to the broader community, the example I give is that in Europe, you have this appliance ratings. You can have a AAA washing machine. If you run it with no load, you still use electricity, you still use energy, right? So I think you need to have some way of measuring what is actually being delivered as output.
So, yeah, it's basically if you buy a car, they say like, I don't know, mileage per gallon or mileage per kilowatt or whatever the number, right? And when
actually with electric vehicles is a great example because it's far from what they quote.
Right. Then when you're really like running it, you may not be getting the same number what's getting published, right? So you need to have both, right? Static is when you buy the system.
Yeah.
And dynamic is when what you're really getting it. And it may degrade over a period of time, depending on error rates and other things that you're going to see, right? And also it's all depending on how you connect the systems together, right? When you're in a static environment, you're probably putting ideal numbers there, right? In dynamic case, your network and your storage, all these external factors runs into the picture of what number you're going to get out of it, right?
I think you need both. For example, when you're in a spec workload, CPU workload, you get some number, right? Both int and right, spec int rate and floating point, etc. But in the real life, you may have a proxy or a real life workload which may simulate a spec CPU benchmark in a way. So that's what we need to measure against, right? So we need to have both references in a way. So that way you can point back, refer to it and see, oh, okay, is it
Yeah.
operating at the optimized state or not, right?
Yeah, basically if we design for dynamic, but one mode of that is run at a peak or a particular loads and you get it, right? Then you publish the number, right?
Yeah, so maybe we can go back to first principles a little bit.
Right.
What level of precision do we think is useful or required here for a peak or an instantaneous metric?
That's a good question.
Yeah, need to be
'Cause
analyzed,
where
right?
we are, right, we've got nothing, right? So
Yeah. Mhm.
even something with 10% slop in it is better than nothing, right? If it's an arbitrary number that doesn't mean anything, obviously that's useless, right? But it doesn't have to be absolutely precise. I don't think we need 1 or 2% error here, right? In terms of
No.
the infrastructure, in order to show where you are against maybe an industry average or a best in class, and whether you're improving or getting better or worse over time, right? I think those are the primary things we want, right? Is where are you against an average or a best in class, and are you getting better or worse, and by how much, right? Directionally, that's the primary use of the utility of this metric, I think. Now, we already brought up here some other considerations, right? Which is if today there's no specific regulation, but that may change soon, right? So if you're required to do at least X well, you establish a metric, and then the powers that be say, great, you have to do at least X and next year Y against this metric, right? If that's how it's going to be used, then we need whatever fidelity is going to attempt to be enforced, right?
So let me bring this other sort of topic to the conversation, since we're talking about regulation. There are economic incentives for helping a customer figure out how they're using their electricity, right? So this doesn't have to, the metrics do not have to be metrics that just need to satisfy regulation, but they add value to the product.
Agreed.
Right.
Yeah.
And
yeah, well,
so,
and obviously most people have to pay something for energy. Even if you generate your own, that costs resources and money, right? So needing less energy is desirable, right? From an operational
it's desirable because you could basically, it gives you optimization. It also gives you an idea as to, based on volatility in energy markets, how to shift your energy. But so that's one thing I wanted to say. The other thing is that, I want to give an example of a metric that is not as useful today, just to bring some value to the conversation. We've been looking at TDP of the same CPU part, brought into multiple form factors, blade 1U, 2U, and the just running a simple micro benchmark that fills in 5 issue slots of core and trying to increase the number of cores, we see that depending on the form factor, the number of cores that we can maintain at the quoted socket level frequency reaches half, and then the frequency goes down. There's nothing you could do about it to keep whatever the firmware believes should be the maximum power for that particular form factor. We do this on other form factor, and we could also bypass the firmware. We could shoot up keep the frequency at 3 gigahertz all the way for the whole socket, but then the power consumed goes well above the TDP. So right. I think the metric, even based on what we're seeing in products today, I think a metric doesn't have to be within 1%, but being within, reasonable, maybe 2 digits of percent is good.
Okay. Yeah. And I recognize that when I postulate that question, it's not there's no obvious way to answer it quickly, but I think, you know, for what you just said is I think useful, right? If, you know, if we had a 10% number, would that be good enough to get started or not, right? That's one place to start, right? Yeah, in the nature of the performance variability you're talking about, we have some data on that, obviously, right? We know why that happens, and we can quantify the range that it spans, right? We actually, some of those specs are visible on some of the parts from some of the vendors, right? Because there's a peak frequency and performance of a core when it operates by itself, and there's a different, because of dynamic voltage and frequency scaling, there's a different performance for all cores when all cores are active, right? So you can, that gives you two behaviors that you may or may not want, right? People may not even be cognizant of these things in a lot of cases, right? But that's why I was saying, when you load up half of the cores, you're 50% CPU as measured by the Linux meter or EMON, right? Some built-in performance counters in the CPU. You're not at 50% performance, because that half of the cores is using all of the power, right? If you go look at the socket TDP, we can hit TDP at 50% load on most of the devices we've produced at Intel. You may not want us to, but you have to tell us not to if you don't want us to, because out of the box, that's what they'll do, right? And so then as you add more active load, you do increase throughput, but the performance of each core is going down, right? Because you're now amortizing the TDP across all the cores instead of half of the cores, and obviously you take a frequency haircut on every core as you add more active cores until you get to the all-core turbo frequency, right? Which is published, right? There's a spec for the all-core turbo frequency. But what you actually realize versus what the part is capable of depends on T-ambient and cooling and other stuff too, right? So you can put the same part, two different systems in two different environments and get different results.
Exactly, yeah.
Right. But that's going to be, you know, if you drop 1 or 2 bins out of 3 gigahertz, right, that's a 4-ish% error, right? And I'm not sure we're concerned about 4% error out of the gate.
No.
Okay, I think this is going to be a topic we need to probably spend a lot of time. But I also want to kind of jump on another topic. I want to get some input from the team.
Okay.
So I think if you know certain documents, if you can share the link, I also have a couple of document link. I will send it out to the team. I think what we should take an IR is first share the links, and we should go through those documents. Probably when we meet next time, we should share some of the existing understanding or the work done, so that we can really like finalize what we want to do on the new stuff, right? I think all of you are really providing really good data, but then we need to really like distill it down on what exactly we want to go on each topic, right? We need to kind of generate a list of topics, but we want to align on it.
Okay. What's your vision on the? So I like the idea of people, you know, coughing up what they've run across, right? So we can create a list of prior work. What's your vision for what we do with all that? Are we gonna?
So this is the one, like I'm kind of saying, like once we align, we want to say OCP performance per watt profile or something.
Oh yeah, sorry, yeah, I get that, right? I was more asking back on your first bullet, right?
Okay.
As we generate this list of 20 or 40 or whatever it is, documents, do you want to just publish an inventory with some summary data? What is it that you want?
Yeah. I think links, and if you are reading the document, give a summary, right? Your take on it, right? Because we don't want to read the whole thing here, right? We want to get some summary based on what you read. What is important for us to consider?
Well, so are we going to have people present summaries, and what do you want in the summaries? I think we'll just have to think about what do you want to do with all of that.
First, right? I think let us share that links, and I think all of us probably at least have a chance to read the docs that already exist. Then if you are reading something, if you can publish a summary, that will be good, because we don't need to kind of rehash the summary. And as long as we align with the summary, then we know like it's useful or not, that what we want to reconsider here, right? think about it. How do you summarize? Or we can say, like, when we come back next time, if you read some of the published papers, if you can give a summary, like if others has not read it, at least they can get an idea what it is, right? Or if you think that something we need to consider, let's put that as a list that we need to be considering it. Okay. The another one, just a quick one. The one I'm kind of trying to create this profile for IUE is really like it's supposed to be said like all the fan power, power supply efficiency, CDU power, and all these things need to be considered and removed. It's not part of your compute energy. It's more of a non-compute energy or non-IT energy, right? The question is, if I look at a lot of Redfish representations, it says these are shared, right? But when you are, let us say, even if you take some probably pixel is good here, if I share this one, and maybe one service is operating at a peak load and another is in ideal, another is somewhere in the middle, right? When you account for the non-compute energy for the fans, how do you want to represent that? And today, Redfish model is saying these three servers is sharing the fan. It does not have that load factor in it, right?
Right. And obviously the fan's going to be set by the hottest piece of equipment.
Right. And if
Yeah,
this guy
well,
is
there's
running
two
high,
questions.
fan may be running, but the
Yeah,
others are not really utilizing that. It's not because of the other guy, right?
Right. Well, yeah. So how do you attribute the non-compute energy?
Right.
Although so lots of interesting discussion. We're not going to solve it in 2 minutes, but yeah, we got to think through the scenarios we're trying to account for, right?
Right.
And that's a more modern scenario, particularly if you start to go to direct to chip liquid. This is a good. It's not the precise picture, right? But
it's same problem exists here, right? Maybe this server is fully loaded and others are sitting in idle, right? And the loss, you want to account for this server or you want to account for everybody, right? It's a similar problem, but we need to kind of align on it, right? Even if I look at storage, right? Your compute systems sharing and your this storage is shared by other compute, then where do you want to account for those things, right?
Yep.
Yeah, so think about it. Let us when we meet next time again, I want to kind of start. I'm also kind of start thinking, putting some mechanism to represent, but at the end we need to converge on it.
Okay.
Are these slides available on the OCP platform, the networking platform?
There's no shared locations available. I don't know whether Eric, any shared place we can
I
put
think
the
we
material.
need to create a files folder for the DCEM workstream. There is a folder for the sustainability project. You can put it there in the interim.
Okay. I will think of offline. I was using FTI SharePoint future technology, but I think that's not a good place.
Okay.
Right. Let me find out from either you or Sruti to find the location, and I'll put the material and send a link here.
Thank you.
Yeah, we obviously do need a place to share material. Yeah.
Right.
Okay.
Okay.
So we can get that cleaned up.
Sure.
Great meeting, everyone. I have to go.
Thank you, Tim. Thank you. Nice
All
to
right.
see
Talk to
you.
you. Bye.
Yeah. Bye.
All right.